Hi everybody, I just received this parcel from PCBWay, and as usual PCBWay is sponsoring this video. So thank you PCBWay for this sponsorship. Inside the box, as usual, 10 PCBs. What are they for? They are very tiny, and as you can see, one ESP32 can stand on the top plate, top face, while all the electronics, which is almost nothing, will go on the bottom side. You will find there an optocoupler, a diode, and a few resistors and a MOSFET there. What is this board for? Well, it is specialized for Linky French electrical counter, and this board is able to sniff the TIC Teleinformation signal coming from the Linky counter. So this video is more or less only for French people. However, I will try to speak in English. I have already soldered this tiny board, tiny but compact in fact, because as you can see, on one side there is the ESP32 Lolin 32 light board, which is powering the system, and the PCB are more or less exactly the size of the MCU. And on the other side, as I said, I have soldered the optocoupler here, a diode and a resistor. These are used to limit the current coming from the TIC signal. So the current is going into the optocoupler, and then the output of the optocoupler is triggering this tiny N-channel MOSFET, which is inputting the serial port of the MCU here on the pin 16. The TIC signal is 50 kHz modulation of a serial UART signal. And this signal has two configurations, one which is historical and one which is for the new standard. I do have the historical configuration on my counter, so it is something which is rather strange in terms of baud rate. The speed is only 1200 bauds. You can change the historical to the standard format, requiring this to Enedis, the electric power provider in France. But I will stay on the historical channel because it is probably more easy to decommutate the UART signal from the historical channel rather than trying to decommutate the TIC signal from the new Linky system. However, this schematics is obviously able to do both. What is quite different from other TIC boards that you can find on the internet, it is not the electrical signal schematics here itself, because this one is very popular and directly cloned from Alar blog. So it's something which is very reliable. My advice is to stay carefully with recommended resistor value if you want to have a proper decommutation of the signal. Apart from this, it is very easy to solder. You have the component on this side and the ESP32 on the other, on the mezzanine. What I have done is that I power the MCU with the USB plug here. I am not salvaging the power from the Linky because it is way too weak to allow a real-time decommutation. And so this consideration of saving power and only emitting the frames one time per minute was not what I wanted to do. I wanted to have a real-time decommutation of the current and the power and send them to my home assistant domotic box. And this is now done in real time using an MQTT, message queuing for telemetry transfer, which is a very reliable system. I have added also on the board here 3-pin connectors and a resistor in order to connect DS1820 DS18B20 temperature sensor in order to monitor the temperature in my garage. So you will find the code, the source code of this Arduino sketch on my GitHub pages, as well as the documentation for the whole project and the capability of ordering the PCBs directly at PCBWay site. It's very cheap. As you can see, the quality is perfect. It's very professional looking. It's easy to solder. Don't hesitate. This configuration is only costing, let's say, $10 or €10. So it's very easy to do. It's directly integrated into Home Assistant. You don't have to write YAML code and something like this. Just compile the code and then you will find the Linky device into your MQTT integration, and it will output the current, the power, and the index of the counter, as well as the temperature if you put the DS18B20 there. So goodbye. Have a look to the links if you want to know more and see how to integrate all this into Home Assistant.